Okay, now we're going to do 6.2 number in the exercises number 5. And I may just put that in the way. Okay, so we have the same thing, this little thing that we've had in 2, 3, and 4. But this time, it's y equals x to the 6, y equals 1 at y-axis, y-axis, y equals 1, y equals x to the 6. That's the region. But are taken around y equals 5, not 1, but 2, 3, 4, at y equals 5. So the other part of this will be right where I wrote. So I'm going to have to erase some of this here, get that out of my way. So this is 1, 2, 3, 4 from it. So 1, 2, 3, 4 would be there. And 5 and going this way. So this is not spread out as far as number 4 was. So if I do the disk method, there would be a hole in it. I would be slicing perpendicular to the axis of rotation. So the slice would go this way, and the formula for disk, if there's a hole in it, is pi large radius squared minus the small radius squared. The thickness of my slice is this way, which is dx, and my large radius is here, from here to there. Now to express that, that's going to be almost 5. It's going to be 5 minus this little bit. And that little bit, this is the point on the curve, that little bit is y. Remember, it's over x up y to the curve, so that little bit is y. And then the little radius, well, that's this inside. It's always the same amount. It's always 1, 2, 3, 4. And we're doing this dx. It's going to go from 0 to 1. And everything looks pretty good except for this is not an x. Y is x to the 6. So we're going to have pi integral from 0 to 1 of 5 minus x to the 6th quantity squared minus 16 dx, which would be pi integer of 0 to 1 of this squared would be 25 minus 10x to the 6th plus x to the 12th minus 16. 16 from 25 is 9. So now I can do the antiderivative, and it would be pi 9x minus, goes to 7, so it would be 10 sevenths x to the 7th plus 1/13 x to the 13th, evaluated from 0 to 1, and I'm going to get pi 9 minus 10 sevenths plus 1/13 minus 0, so that's it. Let's see what that works out to be. Pi parenthesis 9 minus 10 divided by 7 plus 1 divided by 13, and I get 24.0280001. Okay. Now let's do it with the ring method. Now, I didn't ask you to do it on this. I think 2, 3, and 4 is all I asked for, but I'm going to do ring on this one because I think it's going to actually be a little bit easier. So there's the slice. Its thickness is up and down. So it's dy. It's parallel to the axis, the slice, and it would be up here, and that piece of pipe would come whoop. Okay, I didn't make a real good arcs on those, but that's the idea. And the ring method would be the integral 2 pi r h dy. And y is going to go from 0 to 1. Now, the height is this, because I'm thinking about this sideways here, how high this piece of pipe is, how long the piece of pipe is, the height. I call it that on a cylinder, so that's why I'm calling it a height. The height is over to the curve from the y-axis. That's always the x value. Once again, x, y. Going over to a point on the curve is x. So the height is x. The radius is from here to the curve, which is going to be, just like we had before, the large radius, which is going to be 5 minus y. Well, that's already in terms of y. The x is the only thing we have to be worried about. And x is equal to y to the 1/6. So this becomes 2 pi, antiderivative, 0 to 1, 5 minus y times y to the 1/6 is what x is, dy. Distributing that, I get 2 pi 0 to 1 of 5 y to the 1/6 minus y to the 7/6 dy, which equals 2 pi. So if I add 6/6 to 1/6, I get 7/6. So 5 times 6/7 y to the 7/6 minus, add 6/6 to 7/6, we get 13/6. So we get 6/13 y to the 13/6. Evaluated from 0 to 1. If I put 1 in here, I get 2 pi 37 minus, put 1 in here, 6/13. Put in 0, I get 0. And so hopefully this will come out to be this same answer we had last time. 2 pi, parenthesis, 30 divided by 7 minus 6 divided by 13. Voila. Oh, I'm so happy that I'm getting right answers for a change. Good.